So children, now that we've understood angle of depression, let's quickly see and check whether the given question can be solved. Now look at this picture. You've seen a ship and you can see kind of a submarine. Now this is being done by a student. Take 10 seconds and see whether theta is the angle of depression. Yes. Now what's the answer that you've got? Okay, let me discuss. Children, theta is not the angle of depression. Angle of depression is generally the angle which is made by the line of sight and the horizontal level, right? But here, theta is the angle that is made by the line of sight and the perpendicular distance. So rather, theta is not going to be the angle of depression. The angle of depression is going to be the other side of theta, which is going to be 90 minus theta. Now this is a very common fallacy by students, and many students, they tend to lose marks in such questions. Yes, the angle of depression is actually the angle of elevation. It makes a, yes, it makes a Z. Now some applications of trigonometry in astronomy, let's quickly go through that. Since ancient times, trigonometry was used in astronomy. The technique of triangulation is used to measure the distance to nearby stars. In 240 BC, a mathematician named Eratosthenes discovered the radius of the earth using trigonometry and geometry. It's a very well-known fact. Now let's come to a very recent fact, which was in 2001, a group of European astronomers did an experiment that started in 1997 about the distance of Venus from the Sun. Venus was about, yes, this many kilometers away from the Sun. Can you see the distance? Now let's quickly move on to some questions that you can expect in exams or that are directly related to your content. Now look at this, the situation. From a point 20 meters away from the foot of a tower, the angle of elevation of the top of the tower is 30. Find the height of the tower. Now look at the figure. If we say that AB is the tower, C is the point which is 20 meters away from the foot of the tower, and the angle of elevation is 30. We need to find height of the tower, that is AB. So let's read. Let AB be the height of the tower and C be the point. In the right triangle ABC, tan 30. Now what is tan 30? It's going to be perpendicular upon base. Yes, here you got it right. The base is AB and the base is BC and the perpendicular is AB. So you get tan 30, 1 by root 3 is going to be AB upon 20 and AB is going to be 20 upon root 3. Now we cannot leave 20 upon root 3 like that. We need to rationalize, and putting in the value of root 3 you get 11.56 meter. Again, let's quickly analyze what will be angle of depression. Good enough. Let's move on to the next question. A balloon is connected to a meteorological ground station by a cable of length 215 meter inclined at 60 degrees to the horizontal. Children, I think the question is the same, just that the premise of the question and the language of the question has changed a bit. In the previous example, the distance on the ground was given to you. Now the hypotenuse is given to you. If the hypotenuse is given to you and you need to find height, that is, h is given to you, you need to find p, and so we're going to use which trigonometric ratio? Yes, we're going to use sine theta. So sine 60 is going to be AB upon 215. Putting in the value of sine 60, which is root 3 by 2, you get the answer. That's pretty simple. Let's move on to the next example. It says a kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degrees. See children, in both the previous examples, the language was a little different. Here it says the inclination of the string with the ground is 60 degrees. Now the key words here are two words, inclination and ground. Inclination means the angle to the ground. Angle to the ground means, yes, angle of elevation. So these are different words that can come up in exams. That is, different words, different terms can be used for angle of elevation and depression. Find the length of the string, assuming there is no slack in the string. No slack in the string means the string is straight taut. Let A AB be the height of the tower? Same way, AC is the length of the string. We're going to use, yes, sine 60 is equal to AB upon AC. And finally, the answer turns out to be 40√3 meter. Now let's come to a little more complicated example. The angle of elevation of the top of a hill at the foot of a tower is 60 and the angle of elevation of the top of the tower from the foot of the hill is 30. What does it mean? Very confusing? Let's read again. The angle of elevation of the top of a hill. Now what is the hill? Let AB be the hill, right? And DC be the tower. We are assuming that the hill is higher than the tower, right? Let H be the height of the hill and X meter be the distance between the foot of the hill and the foot of the tower, right? They say the height of the tower is 50, so DC is 50. Look at point A. Point A is being seen from point C at an angle of 60 degree, and same way to look at point D from B, I need to lift up my eyes by 30 degrees, so that's the angle of elevation. So let H be the height of the hill and X meter be the distance between the foot of the hill and foot of the tower. Now this gives rise to two right triangles, children. The first right angle triangle is going to be ABC with angle B as, yes, B as 90, C as 60, H as a perpendicular and BC as the base, that is X. Same way, I'm going to have another right angle triangle BCD, wherein angle 30 degree is the angle which I'm going to consider for my trigonometric ratio, whichever is applicable. C is 90 degree and DC is 50. So in right angle triangle ABC, cot 60 is going to be X upon H, right? And X is H cot 60. Now why are we finding the value of X here, children, is that X is the common term which is applicable or which is used in both the triangles. So in right triangle ABC, you have cot 60 is going to be X upon H, and in triangle BDC or DBC, we're going to cot 30 is going to be X upon 50. So in both the cases, if I get the value of, put in the value of X and equate, I will get the value of H directly, which is 150 meter. It's just a matter of cross multiplication and a bit of calculation here and there, children. If you're clear with the concept, this concept of applications of trigonometry is going to be an extremely easy and interesting thing for you. Now we know the height of the building AB. We will first consider the right triangle GAB. Now what does this mean? Look at this figure. Children, let's do something the opposite. I'm going to give you the figure and I'm going to give you the solution here. In your minds, you should be able to formulate a question. Okay? While if you're watching this video, I would request you to pause the video here, look at this screen and formulate a question yourself. If you're able to formulate a question, if you're able to frame a question, I don't think you'll ever get a problem in understanding any trigonometric question like this. Now let's come to a question which is an amalgamation of angle of elevation and depression both. Now, from the top of a tower, let AC be the tower. The angle of depression of the object on the horizontal ground is found to be 60. So if I'm saying AC is the tower, from a horizontal line is there and the line of sight is going to be AP. So yes, can you see 60 degrees the angle of depression? Correspondingly, angle APC is going to be the angle of elevation by alternate interior angles. On descending 20 meter vertically downwards. So let's say that as you move vertically down, straight down 20 meter, I reach a point B, so that AB is 20. Now from B the angle of depression is 30. Right? It says on descending 20 meter vertically downwards from the top of the tower, the angle of depression of the object is found to be 30. Find the height of the tower. So in right angle triangle ACP, you've got 60, tan 60 is going to be H upon X, and same way it's going to be in triangle BCP, tan 30 is going to be H minus 20 upon X, right? Now here, putting in the value of X on both sides, you get H as 30, and so the height of the tower is going to be, height of the tower is going to be 30 meter. Now children, as we move towards the end of the video, let's quickly revise what is angle of elevation and depression. Now this is a man standing, and can you see the horizontal line at which this man's eyes are the horizontal line at which the eyes are placed. There's an object above and there's an object below. To look at the object above, we need to lift our eyes from the horizontal line. That's called the angle of elevation. And as we lift down the eyes, move my eyes down towards the object, that angle which makes with the line of sight and the horizontal line, the line of sight and the horizontal line like this is called the angle of depression. So children, see you in the next video. Hope you enjoyed it. Thank you.